Hello, everyone. My name is Bren,
And my name is Jem.
and this is the Trunk2Tale Podcast, in which we're seeking to humanize healthcare through the sharing of stories.
And this week, it's really great to introduce my friend Carlo DeLillo from University of Leicester, who's a psychologist. And Carlo and I have known each other for quite a long time. And we started working together on something that I'm hoping to catch up with the news on, which is his foraging game for dementia. And yeah, we got students involved in trying to make a platform for him that would make the game more accessible, and then maybe do some data sciencey sorts of things with the information we got from it. And that's about as far as we got, and I have no idea where he is now. So welcome, Carlo. It's really lovely to see you.
Thanks for inviting me to this.
No, it's we love to have a variety of different sorts of people, and psychologists very interesting. And I wanted to start off by, why are psychologists interested in dementia?
Well, the psychology is very wide kind of subject. So those different psychologists will be interested for very different reasons in dementia. And it's obviously a big problem, and everybody wants to kind of try to contribute to alleviate it, or to make it possible to kind of understand it better. And so psychologists will tackle it from the emotional point of view. I mean, the dementia not just cognitive decline, but really involves emotional responses and reaction to the environment and so on. And so, from many different perspectives, psychologists can be interested and make a contribution. In my specific case, I'm interested in cognition. So I'm an experimental psychologist as a background, and I was interested in aging more in general, and I'm interested in cognitive change and what makes cognitive growth, for example, to change from infancy to adulthood, what makes people efficient in managing information and solving problems. And so I was also interested in how these competencies decline. And so dementia is an aspect of that. It's a kind of pathological aspect of cognitive decline. But I've also got some theoretical interest in it, because there are some approaches and theories that suggest that Alzheimer might actually be something that originally was adaptive, and then became a kind of something that leads to kind of pathological conditions in our modern environment and so on, because I had an interest in kind of the evolution of cognition, and I'm also interested in that particular aspect and the predictions that can be made based on this, about what should really be mostly impaired in terms of cognitive functions, and because of the reasons why this might be impaired that originally were useful things to happen in our organisms. Then if we can compensate some of this decline with particular interventions that might tackle those aspects of cognition that decline.
Can I quickly ask a question, Carlo, coming at this from more of a lay perspective? You said that what we now know as Alzheimer's may have been adaptive. So it was something that was useful to human beings at some point, but that then, I don't know, you'll explain.
Yes, well, it has been suggested that because the brain is a very is an organ that uses quite lots of energy, and so it's got very high metabolism. And this, again, according to some theories, most of our most advanced kind of cognitive functions and parts of the brain developed as to allow us, or as a kind of our kind of primate ancestry, to forage efficiently in particular conditions. And so those skills that allow us to forage efficiently might be particularly useful early in life. And so that's when we require quite a lot of energy to be used by the brain to start to understand what are the regularities, what are the aspects of our environment that allow us to forage more efficiently there. But then when we get older and we actually learned some of these constraints, some of these regularities, some aspects of the environment, then it becomes less useful to have these skills, which are psychologists sometimes are referred to as fluid skills, such as attention, working memory, and so on. And so it might actually be useful to start to have some cell death and some reduced metabolism, because we don't need any more those functions that we needed early in life. And while we had kind of shorter lifespan, then this was kind of adapted, didn't get to the stage where Alzheimer can get us in modern societies, when in a modern kind of environment, when we live for much longer, and so it got time to become such a devastating disease before we wouldn't got to that particular stage.
Right.
I mean, that's all kind of theories that are.
It's interesting. It reminds me of something I heard actually in relation to illness, that in areas of great poverty where there was a lot of disease, the body built up immune responses to those diseases. But when welfare became much better, hygiene became much better, social conditions became much better, that response was no longer needed. Turns on the body itself. And it was actually the study done in Glasgow, and a lot of people there were getting illnesses at far earlier ages than they were in other places. And it sounds a little bit similar. So you used the word foraging. Sorry, Jem, you go ahead. Yeah, sorry.
I was going to ask, how does the theory help do anything about it? I mean, so you say, there's this theory that it's like this, but what's that going to help a psychologist or a clinician improve things, knowing how it, having some other explanation? Is there some pathway in the brain or something that it means that you've got to fiddle with, or what's the consequence?
Yes, well, in terms of how we can improve, as far as I know, I think there hasn't been very much success in terms of slowing down the disease or reversing it. But I suppose we can keep trying. And one thing that I think might have some promise is are forms of brain stimulation that might actually help increase metabolism in some parts of the brain. Now, as far as I know, again, those particular forms of brain stimulations haven't been very successful, especially in relation to kind of improving cognition and in aging and in Alzheimer, but have had some effect. For example, in they're used in the NHS sometimes for trials that are trying to help people with depression and so on. But one of the reasons why it is not so desperate, the situation, we can be hopeful, is that this techniques, I'm talking in particular about this particular form of brain stimulation, which is TDCS, which stands for transcranial direct current stimulation, which is a very mild kind of form of stimulating the surface of the brain, actually passing a current over the surface of the head, the scalp, and it's used in gaming, so it's something that is non-invasive and very accessible, very not very expensive to buy, and so on. And the problem with it is that it's got so many parameters that you can change. So you can stimulate different parts of the brain, you can change the voltage, you can position these electrodes in different ways, you can have repeated sessions with this. And so I think there is scope for trying more of these changes in parameters to see if any of these could be potentially effective. So the notion that Alzheimer might be associated with this reduction of metabolism, if we understand it better, which functions could be enhanced by increasing metabolism of particular parts of the brain, then potentially we might lead to some useful interventions. But yeah, again, that's.
Let me just ask you, when you explain about applying electric currents to people's heads, what sort of response? Because we're all thinking of that Frankenstein thing where Dr. Frank and Igor, they've got these big things and then they zap him and he comes alive, or electric shock therapy that's One Flew Over the Cuckoo's Nest sort of stories. Are people still, when you talk about that sort of thing, people still a little bit, I don't like the sound of that? Or do you think that people are relatively sanguine about the idea of electricity being passed through their brain?
I think it might also be age dependent. I think younger people might be more, less worried about it. And as I mentioned, I think some people use it even in video gaming, and I think it's something that you can buy in books. Right. Some versions of this. It's like a very, very. It's just the idea that is an electric stimulation, but it's a very, very, we're talking very, very mild voltage. You don't feel just a little bit of maybe tingling kind of a sensation. But it's non-invasive and not dangerous or anything. But I can see that some people might have some resistance just because of the idea of having the brain stimulated, having current over passed over your head.
So Carlo, we're interested in you've created a game. You used the word foraging earlier when you were talking about adaptive behaviors, and you've invented a game which apparently uses this concept of foraging. Is that correct?
Yes.
To cognitively assess people at different stages of life. Could you explain a bit about your game?
Yeah, it's a very, very simple game that kind of tries to capture some aspects of real foraging and kind of for fruit in a forest, but it's very streamlined and very abstract in a way. And so it just consists in basically can be presented on a touch-sensitive kind of device, such as a tablet or a phone, but it's better to have a larger screen, really. And there are a number of shapes that are presented, and people are given very, very basic instructions, like you touch these shapes until you find the apples. And so you just touch those shapes, and some of those will show an image of an apple when touched. And you do that several times. So every time you get a set of shapes, some of those will reveal an apple when touched, some of those won't. And then once you find all the apples, the task will be presented again several times.
Right.
And basically, it's a very, very simple task. So it doesn't really require too much of kind of an ability to solve the task. Even if you touch these items, these images randomly, unless you really get stuck with touching a couple repeatedly and not moving on to touching the other ones, you eventually find all the apples. But so it's something that should be quite engaging and not frustrating for people that might have some cognitive impairment, and at the same time, yes, can be kind of quite fun to do even for people that don't have much of cognitive impairment. And but the way in which people do this, so spontaneously, the way they approach the task, then allow us to derive a number of measures. So the structure of the task is that there are, at the moment, this is a very, very simplified version that we are using for this purpose, but derives from research that we were doing with more complex versions of this, just with young people to assess some predictions about cognition that should be involved in particular type of foraging situations. And so in these very simplified versions, there are three shapes that are presented. So there are 12, I think, overall. And so there is 4 of one shape, 4 of another, and 4 of another shape. And in any particular trial, there will always be 4 apples to be revealed. Yeah,
right.
And those will be, in one particular trial, will be one particular shape that, if touched, will show the apples. Then in a subsequent trial, it will be another shape that will show the apples when touched. And one of these sets, so there are 3 sets, 2 that will alternate in the way in which I've just described, and 1 that never will produce apples when touched. So this is a very, very simple structure there that, again, people don't need necessarily to understand, because it's only 12 things to touch. Eventually they find these 4 apples, get a little thing that tells them that they've moved on and so on, then they can move on. And but by doing that, we can actually look at how efficient people are. So obviously the more, because there are 4 apples to be found, the optimal thing will just be to touch those 4 icons that will produce the apples. So whatever touch that you make in excess is an index of inefficiency. So we can look at how long does it take, how long in terms of how many touches people have to do to find these 4 apples. And we can look that across a period of time, so to see how people improve in doing this when they get this task repeated again and again. But then also, so this is a general measure of foraging efficiency, if you want. The more you spend in terms of searching for these apples without finding them, the less efficient you are. But also this can be divided up in a number of different measures. So you are inefficient because, so you make many touches. You can do that because, for example, you touch those items that never produce an apple, for example. And this is something that if you do the task a few times, you can actually learn and know that some of these shapes are not worth touching because it will never show an apple. And that is something that once you have learned it, should consolidate in your memory, and it's something that you will benefit throughout all the rest of the trials that you are doing. Yeah. So for psychologists, this is a measure of learning and long-term memory, something that, for example, in the brain might be mediated by structures such as the hippocampus, that and other areas that allow us to consolidate information and store it in the long term. But then you also can make other type of, if you want, redundant touches, things that you do and they're not necessary, which is, for example, during a particular trial, if you go back to an icon that you have already touched, that again, it doesn't produce an apple. So you want to avoid within a particular trial to go back to locations that you have already selected, to icons that you have already selected. So we can look at how many times people do that and how they improve again over time to avoid that. And this, by contrast, is a measure of working memory or short-term memory, because it's something that you can only monitor, if you want, while you are doing one particular trial, one particular presentation of the task. And when the task is presented again, your memory buffer has to be cleaned, because now you have to start again to monitor what you are doing in that particular episode, if you want, of foraging, that foraging bout. And so that is a measure of working memory rather than long-term memory. And then also, because these 2 set of items that produce apples alternate, so if it's one particular foraging bout is one type, the next one is going to be another one, then there is the possibility that people start to predict which one is going to be the right one at any particular time. And so we can look at when people select their first item, in between the two that do produce apples. Do they go for the right one from the beginning or not? And that again is something that is also used to test in animals and rodents and so on. The functions that are related to the attention and the more, sometimes we refer to them as executive functions. So more attentional things that allow us to kind of alternate, keep track of patterns and detect structure in regularities in the environment and so on. And so even if it's very, very simple task, but allow us to derive, and these are just 3 measures. Now we are looking at other things as well that can be of interest and particular sub-strategies that people might use. So it's very simple, requires very simple instructions to engage with it. And at the same time, we think my work almost as a mini battery of cognitive tests, because it provides all these different types of measures that are related to different cognitive functions that might be differentially impaired in people with different conditions, including Alzheimer's.
So, can you remind us of what the name of the we won't ask you for what the name means.
Well, at the moment, we call it forecast because it refers as a kind of an acronym for Foraging for a Quality Cognitive Assessment Tool. Because one of the main reasons we are doing this is because we aim to develop it as a screening tool, really, for detecting possibly people that might be more likely to have early signs of dementia, and so they might require further assessments and so on to verify that. And that's something that could be, for example, used in memory services or even GPs and so on. And the main motivation for this is that it's a task that is culture independent, and it doesn't require long verbal explanations for people to be able to start and engage with it. And so because there is an issue in terms of people from different cultural backgrounds that might not speak English as the first language, from different ethnic minorities and so on, that might be misdiagnosed for the dementia, or might not really engage with services and so on, because some of the tools that are currently used as screening tools tend to be very much based on language and require instructions, require people to have translators that explain what to do and so on. And so we think it might have some value, really, as a tool that is simple to administer for that purpose, and can be accessed by and used by people that might have very little English and might not have the same cultural background as
On this point, Carlo, how many people have you managed to get to play the game? And then what you were just saying about it being somehow culturally neutral, is the evidence from the people you've tried it with that it is culturally neutral, or you haven't been able to gather enough evidence?
Yes, we are at the moment where we are kind of quite not informally, but getting as much information as we can with the potential users in order to understand, first of all, if people engage with the task, how happy they are to use it, and if they manage to go through all the different repetitions of this task that we have in mind that will allow us to derive the right information. And we have been doing this in different contexts. So the people that we have engaged with are quite varied. And so far, I think we have tried it with about 50 people, and of which about 20 with my declare, for some reason we know that I have a diagnosis of dementia. and but other people also carers, and I've also been as one. It's been super useful to have the support of Age UK, so they allowed us to go to some of their memory cafes, and some of those are memory cafes that are mostly with people that speak Hindi, Gujarati, and so on. So they include people that not have English as their first language. Obviously, they live in Britain, so they have some understanding of English anyway. But but because it's done quite informally, sometimes we go to these memory cafes, and we only are able to let people try this task at the end of their session, and whoever is interested. So we got very many. There are lots of variation really in the people that even the people with dementia, different stages of dementia, and so on. So we can't really at this stage make proper statistical analysis. We got some descriptive statistics to that seems to indicate that there is something there to be picked up, but really we need to test many more people and do this much more thoroughly. But it seems that at the moment doesn't seem to be an obvious difference between people from, let's say, different ethnic backgrounds and so on. Might not English as first language to use it. It's more like other individual variations that mostly, I think, probably the severity of their condition that makes the difference in terms of how well they engage with the task.
Yeah, Carlo, I'm aware we've only got a few minutes left, and we generally like to close on a note of optimism about it. And I know that you and I, when we were working on this, it was all about really trying to make this game as accessible to as wide a range of people as possible, because the way you explain the game, it to us numpties who don't know anything, it sounds like a fantastic idea. Right? So, it would be great again. So how optimistic are you about being able to get this used in by much larger groups of people, so you can start to get proper statistics? And how do you think we're going to get there?
Well, it's obviously this before it can actually be used, we will need to assess, these cognitive changes with a much larger group of people, and for that, I suppose we need funding, but also will have to be done in several stages, I think. In the first instance, we'll need to collect more data and to derive our statistics about the difference in the groups and so on. Then we'll also need to assess how this tool relates to other known tools for cognitive assessment, and so see if it can actually measure something different, or it can be used as a replacement of other more we want longer and more complex, more verbal, more culturally biased kind of cognitive tools. So I think for that there will need to be several iterations of kind of experimentation, and yes, some funding for recruiting large groups of people with diagnosis and different stages and so on. But there could be other strategies as well to kind of try to get many people involved, and on some platforms where people can actually just go there and assess it. The problem is that, and then try the tool, and then we can derive some information, like kind of large data set. But the problem with that is that we don't have, we don't only rely on what people declare if they have particular diagnosis or not. And I find that is, it can be a problem unless you got somebody to kind of verify and kind of definitely validate what the statements of the people involved or the carers are when they use the tool.
Well, it would be great, Carlo, if it achieves its goals, because I was with my mother when she had to undergo the language test for dementia, and to be honest, I think she'd have much preferred to pick out apples from your game than than engage in any. Apple was one of the words actually that she was asked to remember. I recall. Thank you for your time, Carlo. That's been wonderful.
Oh, thank you very much.
I'd love to bring you back on again. When things have moved on a bit, we'll bring you back on and you can update our massive audience on Anyway, great to see you and bye,
Thank you,
everybody.
Carlo. Bye-bye, everyone.
Thank you very much.